Hello everyone, this is Kapil John and today we'll be discussing some collabs related to clustering assignment. So from the start we have k-means algorithm from scratch which is implemented using Python. So we'll import k-means and everything and we'll read the training data which we have. Here we will validate using the k-means algorithm that is present in the K sklearn cluster. We'll try to visualize the data. We'll encode categorical values, and in the next step, here we are defining a data frame cluster where we are giving the y predicted value, and that's we are using cluster centers. So we have uh, 6 cluster centers. This is how they look like. Actually, 4. Yeah. So um, once we're done with that, we'll see how clusters are formed. This is how they are formed. And I will plot it. Let's go further. Now on to the next collab. This is hierarchical clustering. So it is, in this we'll be using simple example. We'll start with importing the data. We'll use um, synthetic data and we'll scatter and plot. So this is how the cluster should be looking like. Um, then we will go and make a find permutation function. And we'll use some more complicated example where we have to make clusters. So by k-means we are getting these clusters and then we'll be using dbscan and we get these as clusters. Now we'll be using this clustering different digits. So, we'll use k-means and other algorithms. And then we'll start clustering. And here we'll be doing hierarchical clustering. So for that, and this is how we're doing it. For different sepal width, sepal length, petal length, and petal width, this is the iris data. This is the above is the heat map and dendrogram, and that's it for the collab. Let's go to the Gaussian mixture models. Um, Weakness. This is basically coming from the weaknesses of k-means. Here we'll be using k-means, and these are the clusters which are formed, 4 clusters. In this we will plot k-means. This is how it look like. Now, now we're generalizing EM Gaussian mixture. Gaussian mixture model attempts to find a mixture of multi-dimensional Gaussian probability distribution that best model any output data set. In the simplest case, GMMs can be used for finding clusters in the same manner as k-means. So we just call the gmm.predict function and it will give us the labels. Now we'll use the scatter plot and see how it looks like, pretty similar to k-means. We'll draw ellipse on this. So this is how the ellipse looks like. It's scattered over this. So we are scattering over this line. So we are choosing covariance type, which will be spherical and full. So next we'll go to density estimation and we'll use GMM for density estimation. And then we'll go to Gaussian mixture and then we'll go to see how many components we are using. And finally, we are done with plotting this. And the Gaussian mixture is plotted. Let's go to dbscan. So this is a PyCaret Colab which I have run on my computer. We know what is clustering and the data set we are using. We'll get the data set. We'll use the mice data set. The data set shape looks like this, and we'll start the setting them up with the environment. This is how it looks like. And then we'll create the model. K means model. We'll assign the model, and then we'll plot the model. Here we're plotting the model. This is how it is looking like. The K means. Then we'll elbow plot it. This is the distortion score. Uh, then we'll perform the silhouette of the different clusters, and then we'll use the distribution plot and to see sizes of clusters. So these are the sizes of clusters. Very similar. There is a disparity between the 0th and 3rd cluster, but yeah, I think it's fine. Then we'll plot model. Once we're done with this, we'll predict on unseen data, and then we'll save the model. Let's go to the next one. Here we'll be doing anomaly detection. We'll start with installing IOD. Then we'll load the iris data, and then we'll use the random state and we'll shuffle the data set basically. Then we'll apply isolation forest. We are getting this as the output, and then we'll use predict the anomaly score by using a CLF decision score, which is no raw anomaly score, and then we'll evaluate the data using the ROC value. So 64% is not that great. This is how the anomaly is looking like. Predicting these as anomalies. Let's see, and this is the distribution of anomaly score. This is the precision recall curve, and this is 3D visualization of anomaly. This is thing is anomaly. Let's go to the time series clustering. We'll use fast DTW and import all the libraries. In this one, we'll use the plain data. For this one, we'll do some data exploration. This is how it's looking like the data. Now the whole time series clustering will chunk the clustering in the chunk length will be 10 and the clusters will be 6. Let's go on to the next step where we'll be using distance computation. We'll calculate the Euclidean distance, RMSE distance, and then we'll calculate on both of them. We'll try to compute and the function for LCSS, and we'll compute distances using LCSS, and then we'll use a heat map. Here we are using a heat map. We'll use clustering algorithms, different k-means with different distances, LCSS, RMSE, DTW, and Euclidean, and you get um, evaluation. This is how the evaluation looks like. Cluster visualization. This is how the clusters look like. There are 6 different clusters we have over here. Um, these are the clusters found. Now let's go to the next one where we'll be using documents and we'll be extracting embeddings and performing clustering on that. So for that we are using AutoModel, and we are using aging news dataset and the sentence transformers all in one LM, where you will be using Hugging Face for that, and we'll be forming 2 different clusters on this data set. This is how it is looking like, pretty great. Let's go to the image one. We'll select the appropriate image data set. So we'll be using this, the Facebook data set, and then we'll use or audio and install everything. And we'll extract image embedding using image bind, and then we'll load image bind model. Here we are loading the image bind model, and then once we're done with that, we'll make a function to save the embedding batch by batch. So it is saving batch by batch, and once we're done with saving the embeddings, it will we'll see the shape of the embeddings as this is how it is looking like. Now we'll prepare the data for clustering. We have the image embeddings array. We'll make 10 clusters, and this is how the clusters are looking like. This looks pretty great. We'll save the clustering assignment, and let's go to the audio. This will be doing the same. This the difference will be we'll be performing clustering on the audio data set, and we'll be using the image bind LLM only. Here we'll initialize the image bind model, and once we are done with that, we'll use this data set, and we'll extract all the files. Then we'll load the metadata. And once we're done with that, we'll extract audio embeddings with image bind, the same process we followed earlier. So here we are doing that. And then we'll filter audio files, metadata, and then we'll generate audio embeddings. Once we're done with that, we'll reshape the embeddings and save them, and then we'll perform clustering on the embeddings. We'll form 5 clusters. We'll make 5 clusters, and we'll try to visualize them. This is how they're looking like. Audio embeddings are not uh, made properly because we don't have a great model, and that is why we don't get a good elbow score as well. And Silhouette is not doing good because of the image bind usage of image bind, as it is not a great LLM model. Thank you so much for watching this video. I hope you learned something out of this.